They want to know what P we should apply, what P should we apply that keeps this block in static equilibrium, and how would you summarize the result?
So you're going to do, it would be the p-value that is, if you're going for the largest one, it'll be the one that balances the, adds to be 0 with the frictional and the weight force.
Let's talk about it in terms of the two numbers we calculated rather than bringing in the normal and the weight and all that. So basically I need to know, I want this block to stay still. What should I do?
Anything in between the two
That's
values.
right. Right. Anything in between.
Can't actually see the results very well.
So if I apply a load less than 187, it slides down. If I apply a load greater than 334, it moves up. So our summary is that it's in static equilibrium as long as P is somewhere between these two values. Okay, so make sure that, I want you to ask questions if you have questions about this.
How did you find, do you get, I see that it's a factor of 0.2 or something maybe from the coefficient of friction? Is that what we're talking about? If the coefficient of friction is larger, it could break loose and slide down.
Okay, so let's see.
What if it was different?
Well, the coefficient of friction is really describing how rough a surface is, right? So if you have sandpaper, you're going to have a higher coefficient of friction. If you have rubber, you're going to have a higher coefficient of friction. If you have metal rubbing, and this is what we need to know, especially those of you in mechanical or aero. I mean, you're deciding surfaces. Why do you put oil on things? You want to decrease the friction in between, right? And you don't want it to wear down. You don't want to have to replace something. You don't want it to make yucky noises, right? So that's the whole thing. So when, as you could decrease the coefficient of friction, and that's making it slide more easily. So if we increase the coefficient of friction and we use rougher surfaces, well then what would it do to our P? Let's see. This goes up, this goes up, this goes up,
Everything's going to go up.
this goes up.
Or to apply
Yeah.
a greater force.
So
Well, actually, your
that's-
just go apart, because the drop, if you increase the friction between them, then P could go down quite a bit, right? It would still just stay there.
So this is the one going up, right? So here, if this increases, this increases.
Yeah,
If
then
this
just-
increases, this increases. P would decrease. Yes, there would be a bigger range. Yeah, and you could do the math and check it out and see.
And sometimes you want your tires to stick to the road, so sometimes you want it one way.
Right, that's true. In some designs, you want to make it more slick, and in other designs, you don't want to make it more slick. Correct. Someone else?
How do you get 334.4p?
I plugged in all that. Yeah, did anybody else check my work?
No, so you skipped one step, or you skipped steps, right?
Well, it's
Is that what you did? 'Cause
three.
I was trying to
It's,
figure.
you could, so you have three equations,
Yeah.
right? And there are three unknowns. You could put it in your calculator if you
Okay.
want. With systems of equations, you could put it in your calculator with matrices, or you can plug in Chuck. Whatever you do, that's what you get.
I thought you just found it like in some video. I was like, oh,
No,
crap,
not-
looking at
I can't do that in Python. Okay, so let's do another friction problem. This will be good practice. This will be good practice on free body diagrams. Good, let's do that. Let's do this one.
I don't know if there's something else that I'm missing. Yes, I put this number
Joanne?
and then
Yeah.
Are we only gonna have
For the
friction
normal
between
negative
two
was-
surfaces, or are we gonna
Actually,
account
like
for friction
440 something.
between like a ball and socket
I don't
and
know.
a support?
We're gonna mainly
Use
do
your
2D.
calculator and radians.
On the friction problems that you'll see in this course are 2D.
Ask about it.
When you get to junior level as mechanical engineers and arrows, you'll have some other types of more complex problems. But for all engineering majors, 2D is what's kept in the lower division. Okay, so we have a force here, 500 newtons, it's shown on the drawing, is applied to the end of the cord, which is attached to block A. Block A weighs 2,000 newtons, block B weighs 4,000 newtons. The coefficient of friction between the blocks is 0.3. Coefficient of friction between block B and the floor is 0.2. Determine if the system would be in equilibrium if P were 2,500, and then it asks for the maximum force P for which the system is in equilibrium. I prefer not to plug in 2,500 and then see if it doesn't work. I prefer to solve for P and then compare it to 2,500. So I would suggest doing that. So let's start out like this is a regular statics problem. Write the given and the find. Write the table of all the forces you see. Do a free body diagram of A, do a free body diagram of B, and a free body diagram of those two together. So we're practicing doing statics problems.
Isn't it in the packet?
No, it's not.